My argument in the book is that when we see a computational system being racist, sexist, or ableist, we need to treat it as more than a glitch. We need to treat it as an indicator that there is a larger problem, generally a socio-technical problem, that needs addressing. So it's not just about fixing the code, it's also about fixing humanity.
All right. So, hello and welcome everyone to whoever's listening to this particular podcast. Today, I have with me Meredith Broussard. Meredith is an associate professor at the New York University and research director at the NYU Alliance for Public Interest Technology. Her research interests include using data analysis for good and ethical AI. She's also the author of the book More Than a Glitch: Confronting Race, Gender, and Ability Bias in Tech. And we'll discuss more about this with her in this podcast. It's nice to chat with you today, Meredith.
Thank you so much for having me.
So, just for people who might not know you, can you tell us a bit about your background before you wrote this book? Like, how did you first got interested in AI, or what was your entry point in AI, and how did you go on to auditing bias in AI models?
Well, I started my career as a computer scientist and then I quit to become a journalist. And the kind of journalism I do now is called data journalism. So it's the practice of finding stories in numbers and using numbers to tell stories. As part of that, one of the things that I do is I write code in order to commit acts of investigative reporting. And this is a newer kind of reporting called algorithmic accountability reporting. So sometimes algorithmic accountability reporters will write code to investigate black boxes. Other times we'll write our own algorithms in order to investigate social problems.
I see, I see. And one of your books, like the title is named More Than a Glitch. So can you explain, like, what do we exactly mean? Because it would not be apparent for people who might not have any idea about what AI models are. So what do we exactly mean when we say it's not just a glitch?
Well, let's start with what an AI model is. So when we build a machine learning system or an AI system, we do the same thing every time. We take a ton of data, we feed it into the computer, and we say, computer, make a model. Computer makes a model. The model shows the mathematical patterns in the data, and then you can use that model to generate new text, generate new images, make decisions, make predictions. It's a very powerful model, and it picks up on a lot of patterns that humans don't see. Right. So that's what's happening every time we are making a machine learning model. One of the reasons that I got into the material that I cover in More Than a Glitch is because I saw that there was a lot of confusion out there about what models can and can't do, what AI can and can't do. And another thing that I saw was that there were all of these instances of AI and algorithmic systems being discriminatory based on race or gender or disability. And when something like this happened, people would tend to say, oh, it's just a glitch. A glitch in computer terms is just a momentary blip. It's something weird that happens. It's not really important. A bug is important, but a glitch is not. And so my argument in the book is that when we see a computational system being racist, sexist, or ableist, we need to treat it as more than a glitch. We need to treat it as an indicator that there is a larger problem, generally a socio-technical problem, that needs addressing. So it's not just about fixing the code, it's also about fixing humanity.
I see. And you say this is more than just a common problem. So this is like a technical problem. So help us understand. So when we mean by these kind of issues or glitch or biases, typically people just know that these biases could be just because of the training data. And you say in many of the blogs and also in some of the paras in the book that you have mentioned that these kind of biases or glitches are coded into the system. So can you tell us, explain to us, like, what do we mean? Like, because as a researcher or people who might just have a basic understanding of AI, it's just like if we fix the training data, we can fix these kind of glitches, or biases, basically. So, can you help us understand how are these algorithms inherently problematic in this case?
Sure. I'll give you two examples. One is from Google Images, and one is from the world of mortgage approval algorithms. Right. So, one of the kind of earliest examples of algorithmic bias came when Google Images was discovered to be labeling images of Black men as gorillas. Right. This was a conversation that people started having around 2018, around the time when my last book came out, around the time when Safia Noble's groundbreaking work, Algorithms of Oppression, came out. And Google, to their credit, when it was brought to their attention that Google Images was labeling images of Black people as gorillas, they said, oops, and they fixed it. But how did they fix it? Well, they didn't address the underlying racism of the image labeling system. All they did was they took gorillas out of the list of possible labels, right? So it was like putting a band aid on, a chest wound. Um, on like something that was just gushing. So it wasn't addressing the underlying problem. So quick technical fixes may look like they're addressing the problem, but it's not really fixing things. So that's an example of where it's not about the training data, it's about an inappropriate patch on the system and about a larger issue. But another training data specific issue comes from an investigation by the Markup, which I write about in the book. So, the Markup, which is a really terrific algorithmic accountability reporting organization, did an investigation into automated mortgage approval algorithms. And what they found was that automated mortgage approval algorithms are 40 to 80% more likely to deny borrowers of color as opposed to their white counterparts. And then in some metro areas, this disparity is more than 250%. And you might think, why is this happening? Well, let's look at the training data. Let's look at how these systems are constructed. What's the data that's used to feed mortgage approval algorithms? It's data about people who have gotten mortgages in the past. And in the US, we know from history and social science that there's been a very long history of financial discrimination against borrowers of color. There has been redlining, there's massive residential segregation in the United States. So it shouldn't be a surprise that the mortgage approval algorithms discriminate. Uh, and another mistake that was made was having the developers and the corporate executives having too much faith in the ability of the computer to replace the human system, right? So, could we make the mortgage approval algorithms better if we had less biased data? Absolutely, yes. Does that data exist? No, right? Because we don't live in a perfect world. There is no world in which there is data about a housing system that has not been discriminatory in the United States.
I see. And would you recommend that, okay, if we were to at all fix this particular problem, it would go into the design or social engineering of this particular data set rather than just using blindly data sets to train these models? Or what is something that people are nowadays missing, if at all, in certain applications that AI is certainly proving its benefits? How do we go about developing these models rather and focusing on not creating these kind of issues?
Well, I think first of all, we need to just confront the fact that sometimes we should not be building AI systems. Like, if it is not possible to use AI to, to effectively make decisions or to make decisions that do not worsen discrimination, then we should not use them. Period. Uh, that is not. Uh, that is not something that many people are willing to confront, but uh, it's it's a really valid choice not using discriminatory technology. So, in addition, we also have a practice called algorithmic auditing. Algorithmic auditing you can learn about by Looking at some of the scholarly work, you can also look at what algorithmic accountability reporters have done. So they've published a lot of really great work about their methodologies. I particularly like the methodological appendix that came out along with a Wired and Lighthouse Reports investigation recently called Suspicion Machines. It's a 50-page methodology document, which is just delightful for a certain kind of nerd. And so, at any rate, you can look at the methodologies, and broadly speaking, what we do when we do algorithmic auditing is we look at the inputs and the outputs of an algorithm. We ask what could possibly go wrong, what is the worst case scenario, and then we evaluate, okay, how often is that worst case scenario happening? Because it absolutely is happening. Algorithmic systems are discriminating. If you run an algorithmic system, there are problems with it. If you are pretending that there aren't problems along the lines of race, gender, ability, like you are in for a rude awakening, because once you start looking for the problems, they're there. On the other hand, once you accept that there are problems in the system and once you evaluate your systems for bias, well, then you can start the process of possible remediation, because sometimes there are mathematical methods that we can use to put a thumb on the scale and more evenly distribute the results of the algorithmic system.
Yeah, and I'll put a bookmark to the first point that you made is something what you have mentioned, techno-chauvinism, right? Like the idea of people just using AI to patch anything and everything that they find as a challenge. But I'll maybe bookmark this, and maybe we can revisit this later. Something that you mentioned about algorithmic auditing. So I wanted to ask, like, have you seen organizations adopt this idea of algorithmic auditing on a frequent scale in the recent few years? Because, like you said, like Google Images did something and they just created a patch to solve a particular problem using the easiest way of solution. And first of all, my first question is like, have you seen organizations adopt these kind of methodologies or groups of people who try to investigate this? And secondly, if not, like what are the major reasons that you think that organizations don't still do this?
Well, I think that organizations don't do it because they don't want to uh, confront the problems that they know are there, right? Like you'll hear a lawyer saying, "Oh my God, I don't want to open myself up to that liability." Like if they don't evaluate the system for bias, then they can pretend that it doesn't exist. Uh, that's not a morally responsible way of operating, of doing business. And so the more responsible firms are doing algorithmic auditing. One firm that I often recommend is run by my friend Kathy O'Neill. It's called Orca. It's O'Neill Risk Consulting and Algorithmic Auditing. There are also a lot of open source tools out there that people can use for algorithmic auditing. There's one called FAIR 360. There's one called Equitas. Uh, there's a handful of new methods for evaluating fairness in algorithms.
I have used Veritas a few times, so I think, like, I mean, I have explored. I have not used it on a professional scale, but in terms of research, like we have been trying to understand what exactly it does. So definitely, highly recommend that one. And one of the key things, so we talked about techno-chauvinism, and I want to try two particular points over here. So you have heavily talked about use of AI in medicine also. So I'm going to revisit that particular thing in the that you mentioned in the book. But my idea of so I work on applied research a lot of the times. And most of the times I go to medical conference because a part of my thesis is using AI for medicine. And I was recently attending this conference in Boston called American Academy of Neurology, and one of the keynotes that a person that he was a neurologist for 20 years from Harvard University, and he mentioned something very interesting. He said that people, like students who are applying for specialty in medicine, when they have to choose specialty, 1 out of 6 people don't choose radiology because they think AI is going to replace them at some point down the line. And this was like a study done by, I think, some magazine. I forgot the name because it was in a very fast talk. But in that particular conference, they made a point that yes, AI is in some ways at least helping us screen or automate jobs. And multiple studies and a lot of things have shown that AI can do it almost as good as like humans. So my question to you on in this long particular point is like, why do we find the boundaries? Because you say like techno-chauvinism at some points can lead to problems. So where do we draw the boundaries? Where do we see that AI has a good application versus where there can be some kind of social problems or social biases being dragged in?
Mhm. Well, let's start with techno-chauvinism. Techno-chauvinism is a term that I coined in my last book, Artificial Unintelligence, and it refers to the idea that uh, technological solutions are superior to others. Techno-chauvinism is itself a kind of bias. And I think that once we let go of techno-chauvinism, once we start thinking about let's use the right tool for the task instead of reflexively reaching for a computer, it allows us to make better decisions. Uh, I think that younger generations get lied to a lot about the future of technology. Uh, they just, older generations tell them things like, oh, yeah, everything is going to be computers in the future, and the young people believe it. And then uh, they're kind of confused when that doesn't actually happen. Right. So I think that's what's going on with the situation that you mentioned with radiology. There was an article in the New Yorker a few years ago where Jeff Hinton, who's an AI pioneer, said, "Oh yeah, radiology, like that's going to be gone in another 2 years." Right, and it was in the New Yorker. Like people read the New Yorker, people trust the New Yorker, they think what's in there is true. But Jeff Hinton was wrong about the future of radiology, and that's not the kind of statement that rises to the level of requiring a retraction by the magazine, right? But it is manifestly untrue, but it keeps getting repeated, right? Also, this thing happens when people see things in the media where they think it's happening more often than it actually is, right? This comes
Yeah.
from research about the perception of risk in everyday life, right? So I think that educators need to really re-examine uh, what they're telling students about the future. In terms of radiology, one of the things that I wrote about in the book was the state of the art in AI-based cancer detection. And what I did in order to write about that was I took my own mammograms and ran them through an open source AI in order to show people kind of how it works and you know, what is the diagnostic process. So two things that were really interesting about that. I had a lot of misconceptions about what AI-based diagnostics would be like. And those misconceptions are pretty common because we all have misconceptions about AI. On some level, all of us are thinking about the Terminator when we think about AI. And the Terminator is really fun, but it's also totally imaginary. And there is no Skynet, there is no Star Wars or Star Trek or anything like that. So I had imagined that the AI would diagnose me the way that a doctor diagnoses me by, looking at all of my scans, looking at my entire medical record. No, what the AI did was it took a static image and I ran it through the AI, and then the AI drew a picture, like drew a circle or a box, indicating that this is an area of concern, right? Did not diagnose, just drew a box. Okay, so when you see this actually in practice, you realize the gap between what we imagine the AI is doing and what the AI is actually doing. Because think about our current system where you get test results through your electronic medical record portal and you get them before you discuss them with your doctor. I don't know about you, but I don't know how to read every single medical test result. Uh, it's not really helpful to me to get these test results before I talk to the doctor. It's more helpful to me to interpret them with the help of my doctor, right? So, a diagnostic system where it just draws a box and gives you a number between 0 and 1, like, is not and the method it's using is mathematical pattern detection as opposed to medical diagnosis. That's not really what most people imagine, and to me it's not robust enough to replace radiologists anytime soon. Another factor that is a highly social factor that people have not really reckoned with is one of the realities of how we design AI systems. And I'm sure a lot of listeners will be familiar with this. What happens when you design an AI system is because of the mathematical realities, you have to decide whether you want the system to give you more false positives or more false negatives, right? This is just a choice you have to make. And AI based cancer detection systems are generally tuned to give more false positives than false negatives, which makes a lot of sense. If somebody gets a false positive, then they go into the pipeline for more imaging, more diagnostics, and it's better for the system to say, maybe this is something, I don't know, better, take a closer look, as opposed to false negatives, where the system would say, nope, you're fine, don't see anything, but the person actually has cancer and the machine didn't see it, right? So the cost of a false negative is much, much higher because we're talking about cancer, we're talking about people's lives. And what do we want to do here? We want to save lives. We want to have better detection, better diagnosis, so that we can get people into treatment so that we can save lives, right? So uh, the the fact that the AI system is going to be wrong a lot of the time is not something that most people are ready to deal with. The fact that the AI system is going to give you more false positives is going to, terrify more people. Because what happens when you get a false positive? Well, you think, oh my God, I have cancer. And then it can be several weeks before you actually finish all of the rest of the diagnostic procedures and find out, oh yeah, you don't have cancer. It's the machine was wrong, right? So it's a it's a very human system. It's a socio-technical system, and the people who are advocating for, oh yeah, let's use AI, they're not really thinking about all of the features of the medical system.
Yeah, this makes a lot of sense. I think the application point of like the design of these problems are really critical because a lot of good applications of AI lies in screening, like when it can just aid someone's benefit rather than just using it as an ultimate decision making tool. So it's like understanding where it can be placed ideally in a very low stakes environment is really critical, especially in medical healthcare.
Mhm.
And something I want to get your perspective that I couldn't get from the book because ChatGPT was something that caught off the whole world, and like unfortunately the book came slightly before the ChatGPT thing came. So I wanted to understand, because one of the key things that people are, I would say, tripping over or maybe curious or maybe concerned is ChatGPT is trained on public data, and we don't know what data it has been used, what was the pre-processing technique that was used. And this begets the question that how do I make sure that it is not trained on biased data set? So I wanted to get your
Well, I
perspective.
mean, that's a very easy answer. That question is a very easy answer. It is trained on biased data, period.
Yeah.
Like there's absolutely no question.
Yeah. So I'll maybe frame this question. So would you say that this kind of deployment of ChatGPT in a world where people are just testing, like people from all different backgrounds are testing this model, playing with it, and I don't know if somebody's using it in a professional settings. Do you think, first of all, is like do you trust these kind of models? Because A, we don't know how this particular model was trained on. And secondly, how do we go about algorithmic auditing something like a large language model, which is like a big model? We don't know, how do we move forward?
Well, I think the idea that we don't know what ChatGPT is trained on is not entirely true, because uh, all of the large language models are drinking from the same well. All of them are trained on the Common Crawl data set, for example. They're all trained on the data sets that you can download from the most commonly available data repositories, right? So there are these repositories where people put large data sets that you could use for training, you know, any kind of machine learning system. So all OpenAI did was they went around and gathered up all of those data sets and then used those to train ChatGPT, right? Like it was not magic. There's no special sauce to it. Um, so we know what's in there. Common Crawl, for example, is a data set that was compiled over the course of several years by a group that, collects data from the web. They made web crawlers, spiders that went out and scraped things from the open web. What's on the open web? Well, there's a lot of really wonderful stuff, and there's really toxic stuff, right? Like the entire Reddit corpus is inside ChatGPT. Reddit, really wonderful and really toxic, right? So, uh, you know that you're going to get hate speech and toxic material out of ChatGPT. And then we can also look at some of the great journalism and scholarship that has examined large language models. So even before ChatGPT came out, there was the Stochastic Parrots paper by Timney Gibrew, Emily Bender, Margaret Mitchell, and their collaborators. And in that paper, they warned of the dangers of large language models, and we've seen all of those dangers come true since the launch of ChatGPT. There is also an investigation by the Washington Post recently. Uh, it's called something like, a look inside the websites used to make generative AI sound smart. It turns out that for one of the Google products, one of the Google large language models, the most influential data set was the US Patent and Trademark Office data, right? Which perhaps explains why ChatGPT sounds like, a 34-year-old compliance lawyer. Uh, we also know that large language models are trained on chat logs. They're trained on, all of the fan fiction that's out there on the internet. It's trained on, whatever like dopey content farms there were in the, earlier in the century. So it's not that hard to kind of extrapolate or recognize the source texts for what ChatGPT is putting out.
Yeah. And throughout the book, you have talked up a lot about, like, first of all, the idea of like how should we be aware of potential miscauses of these kind of AI technologies. So I want to at least spend maybe a minute or so to understand also the underestimations of AI, because we know that you have talked about predictive policing, criminal justice, education, healthcare, and many other topics where people should be having like a very cautious eye when they are deploying or developing AI models. But in your opinion, do you also find any kind of underestimations of AI where people have not been focusing? And I want to tie this to what you something mentioned earlier, like public interest technologies, right? So definitely not all tech is bad, because it sounds like, yes, AI is bad, AI is bad. So in your opinion, have you find any of the application arenas where you feel AI has not been explored enough? And if at all it is explored, it would be like better used for social problems?
So I would really like to see more nuance in the way that we talk about technology, uh, and specifically the way we talk about AI. So we tend to want to go at it like AI is good, AI is bad. Well, it's not really that easy, right? Like the binary thinking is really a problem. So I want to add more nuance to the conversation. So one really important step is looking at AI in context, right? Tying it to a particular context. So take facial recognition, for example. Facial recognition is a kind of AI. One of the frameworks that we get in the proposed EU AI regulation is this notion that there is high risk and low risk uses for AI, right? So if we take an AI like facial recognition, we know that it's biased. We know that it's better at recognizing light skin than dark skin. It's better at recognizing men than women. It does not generally take into account trans and non binary folks. And so we know that it has bias. let's look at a low risk use of facial recognition. Low risk use might be using it to unlock your phone. Not a big deal. Doesn't work for me half the time anyway. It's not a big deal. There's a passcode, whatever. But a high risk use of facial recognition might be police using facial recognition on real time video surveillance feeds, because we know the facial recognition is going to fail more often for people of color. And therefore, it's going to have a disparate impact. It's going to be disproportionately weaponized against communities of color or poor communities. These are communities who are already over policed and over surveilled. So the correct solution there for this high risk use of facial recognition would be not to use facial recognition in policing at all.
Yeah. So basically trying to understand what kind of penalties these decision making tools can have that can influence our choice of AI models being used. Like to what extent we are using these AI models has to be, like you said, like it does not have to be binary. Either I don't choose to use it or I choose to use it. But how do I interpret these predictions has to be something that has to be controlled and monitored.
Yeah. I mean, it's a tool. It's like a circular saw. When you have to cut something, you can use a circular saw, you can use a coping saw, you can use a pair of scissors. Like it depends on what tool you need, and you're not going to pull out the circular saw to cut through a piece of paper. You're going to use a pair of scissors. And you don't win if you use more technology, right? Like you
Yeah.
don't need to use AI for everything.
Yeah. And one of the last questions that I have for you for this podcast is like a lot of people who are listening to this podcast are like young researchers, right? And someone like me who recently got started in AI, one of the key things is like we are overwhelmed with the kind of things that are out there on AI, right? So there are lots of people who are over optimistic, people who are very concerned. People say AI is an existential threat, versus we see these kind of biases that AI models can produce. So my question to you is like how what kind of advice you would give to young researchers who are trying to get started in this field, because it just feels like a overwhelming pile of things that people have to choose from before they start working on something that creates an impact or like a tangible impact. So how do we navigate this field of like so many different research interests, and on top of that we have these kind of problems that people should be aware of? Like how do I get started? What should be my starting point?
So I think that examining one's own unconscious bias is a really good starting point. Techno-chauvinism is a really common unconscious bias. And I say unconscious bias because we all have unconscious bias. We're all trying to become better people every day, but we're not there yet. And we embed our unconscious bias in the technological systems that we create. So if you start by doing the work on on your own psyche and recognizing your biases, you can start the work of making decisions when you create systems to be more inclusive. One of the things you can do is you can collaborate with people who have different backgrounds, who have different life experiences, and you can make sure that there's a diverse range of voices in the room when you are designing technologies, because none of us can be expected to think of absolutely every single situation. But if you have diverse voices in the room and you empower everybody to speak up, then you're going to get started on making technological systems that are more inclusive. But also, don't forget that when you make a new computational system, you do need to maintain the older system as well, right? Like you can file your taxes electronically, for example. I would never go back to the paper method of paying taxes personally, but there are people out there who do not have connectivity. The US government still needs to have printed tax forms available, right? So stop, you just can't imagine that computers are going to replace everything and that it's going to work better.
Yeah. It's just like a side-by-side tool that you should have as an option, rather than just eliminating the other option, or like you said, the counterpart that the previous
Mhm.
technology used to have. So yeah, that makes a lot of sense. And I think, yeah, I would say the same thing, because when I was working with a group a few years back, they tried to explore, like we tried to explore the idea of what kind of biases, like in that one, that was like a pure academic group. So they were just trying to understand what kind of inherent biases these models can produce, because certain models tend to fit the data in a certain way versus the other models tend to fit the data in a certain way, and training strategies influence that a lot. So this was like, again, not on the social engineering or social applications of that side, but like it's very interesting that we treat these models as black box, but inherently how they fit or how they find patterns in the data is very, very critical. And those kind of biases has to be understood. I'm not saying that they are bad or good, but it's just like understanding the pros and cons is very important. So yeah.
Mhm.
But yeah, and on that note, I think those are the questions I had in this particular time frame. So once again, I think I'll be leaving a link to all the books and your homepage, which contains a lot of information, to be honest. And yeah, I got a chance to read the book, and I was just recently flying for a trip, so I pretty much read this book on the fly. So
Oh,
but I
great.
definitely would recommend for people who are getting started, because it's an ideal book for people who are recently getting started, or people who have lesser background on AI, to understand. Like it's very simplistic written, so kudos to you for doing that, because most of the other books that I've read who talk about AI, they are very deep into the details and into the grain, so it's very hard for other people to understand. And you cover a lot of topics, which is very interesting, because it's not just specific to one or two domains. And nowadays, when tools like ChatGPT are going to be out there, lots of people are going to use these models, and I don't know what kind of implications these tools would have. So I'll leave a link to that one, and leave a link to your Twitter, because you have some very interesting thoughts there. So on that note, thanks a lot for being here and writing this book. I hope people who listen to this get inspired by you and maybe follow your work.
Jay, thanks so much. Great talking with you today.